No, Erin.
I feel like she would watch the video.
I think so. Alright, so exponentials look like something like this. F of x is equal to a raised to the x power. So essentially speaking, an exponential function is when our variable is in our exponent. Now in this scenario, where our variable is in our exponent, our base can't be negative. Why is it that our base can't be negative? Because let's say our base was -2. And then we raise it to the half power. You guys don't have to write this down. But if our base is -2 and we raise it to half power, wouldn't that be the square root of -2? And what is the square root of -2? Isn't that an imaginary number? For that reason, our base can never be negative. So in all exponential functions, our base a has to be greater than 0. Why can't it be equal to 0? Because then it's nothing, right? If the base is 0, even if you raise it to any exponent, and then it's just y equals 0, doesn't work. We need to be greater than 0, right? But also, a cannot equal 1. So it can't be 0, it can't be less than 0, it also can't be 1. Why can't it be 1? Because then it would equal 1, because 1 to any power is still just 1. And lastly, x is a real number, meaning it can't be imaginary.
Wait, what's a real number? Like just
The exponent always has to be a real number. Oh, what is a real number? Just not an imaginary number. Any number that's not imaginary is real. So as long as it doesn't have an I in it, then it's real. Oh, I wanted to show you on Desmos, but if I go to Desmos, it won't work. All right, I'll just tell you. So if I have y is equal to 2x, do you all have your calculators?
Yeah.
All right, could we do it on your calculator, since if I go into Desmos, it won't show, it will stop recording.
I'm gonna need a graphing calculator. Do you have that?
What happened? You have the phone calculator. Yeah.
I need your compass.
I lost my stylus, so I have to paper notes.
You never take paper notes, Nico. I'm so sad for you.
It's too big for my computer, so
And then you lose
I have to
it.
put it somewhere else. I have to lose it. When it's like that's ready.
Does any stylus work on your computer? Because I have some random styli.
That from Chromebooks.
Yeah.
I'll take one.
Try it.
That's nice of you.
Well, you can't keep it.
Oh, really? Okay. I
No,
usually do
just
that.
use it in this class.
Oh, they offer me to keep it.
No. So I have...
I think my calculator's at home.
That's all right, Nico. You're just a mess today.
Yeah.
So I don't know if it's going to work. On some of the Chromebooks it works, on others it doesn't. It all depends on which version you have. Okay, so this is one, this is another one. I know, but try it. No, other side, other side.
Oh, where does it go?
That's a pen. The other side's a stylus.
Stylus.
Because it's two. No?
Not quite.
No, other side.
What is that?
No, not working for you. Okay. All right. In your calculators, can you guys enter in 2 raised to the x power? And there looks like there should be a horizontal asymptote. Where does it look like there's a horizontal asymptote? At y equals what?
0.
0. That's not a coincidence. And where is it crossing the y-axis? At what point?
1.
At 1. Exactly. That's also not a coincidence. So it looks something like that,
Why
right?
don't it show us like half of that?
Oh, go to Zoom Standard. Go to Zoom Standard. Now, do you see it?
Yeah.
Should you draw that graph?
Yes, you should draw this graph. Okay, now this point, 0, 1, like I said, is not a coincidence. Because if you look at our equation, what value of x will make this whole thing be 1? What exponent makes everything 1? 0. And this is for everyone. Every time we have something, some number raised to a variable exponent, if you plug in 0 for that exponent, won't it always give you a 1 no matter what the space is? Because anything to the 0 power is 1. So this is not a coincidence. This is called our key point, because it's always going to be in this format. And then there's always going to be a horizontal asymptote 1 unit below the key point.
So it's always going to be at 0?
Well, no, because we could shift, and we're going to talk about the shifts. But if there's no shifting, then yes. If it's just some number raised to, some whole number raised to the exponent, then we'll have a key point at 0, 1, and a horizontal asymptote right 1 unit below it. But looking at this, let's answer some questions. We know the y-intercept is the point 0, 1. What's the domain here?
1?
No, look at our graph. X left, X right, what's happening? Infinities. So it's all real numbers. Our domain is not ending. It's going left forever. It's going right forever. What about our range? So range is up and down. Lowest point to highest point.
0
Good. 0 to infinity. Is the 0 included? Is it ever going to touch that 0? No. So we can do bracket 0, parenthesis 0, infinity parenthesis, or we could just do y is greater than 0. Is it a function? Now remember, in order to see if it's a function, we have to see if it passes the vertical line test. Meaning, if I'm able to draw vertical lines and that vertical line doesn't hit my graph in more than one area, then it's a function. So is this a function? Yeah, because every vertical line just touches the graph one time.
So if range is like this, what, lowest to highest?
Range, yes.
So does it hit the 0 though?
Know that there's a horizontal asymptote there. We're never going to cross it. Now, if you guys still have your calculators out, I want you to graph y equals a half raised to the x power. Yay, I like it. It is. So right now, in y equals 2 raised to the x power, aren't we increasing from left to right? Now, when you graph the half raised to the x power, what's happening? It is decreasing from left to right. That's not a coincidence. So y equals a half x. Do we still have the same key point? 0, 1? Yep. Do we still have that same horizontal asymptote? Yep. So we have a horizontal asymptote at y equals 0. We have a y-intercept at 0, 1. Hey, what is our domain? Left to right. All real numbers. Goes on forever, left and right. What about our range? Left and right. Bottom to top.
Same thing.
Y is greater than 0 or 0 to infinity, however you want to represent it. All right, is it a function we're going to see, does it pass the vertical line test? Yes. Okay, so now we're going to talk about shifting. I'll let you all copy this. Okay, so if we have y equals some base a raised to the x minus h power and then plus k, not in the exponent. All right, we're going to have two different scenarios. We're going to have when if a is greater than 1, so not a fraction, the graph is increasing left to right. So now our parent graph is the one we just drew. So our parent graph will be something like that. We will have a key point at 0, 1, and we will have a horizontal asymptote at y equals 0. Parent graph was y equals a to the x. More colors. Okay, so now let's talk about the other scenario. If a is between 0 and 1, So basically it's a fraction. The graph will decrease left to right. Our parent graph will be y equals a half, y equals 1 over a raised to the x. We will still have a key point at 0, 1. And we will have a horizontal asymptote at y equals 0. We're going to put a star and we're going to write, there will always be a horizontal asymptote 1 unit below the key point. Okay, now let's talk about shifting everything. Is anybody still copying this? Raise your hand. So the shifting is y equals a to the x minus h plus k, where h is going to represent the horizontal shift of key point, and k will represent the vertical shift of key point. Notice how there's supposed to be a subtraction here. So if it's like x minus 2, that 2 is positive, meaning we're shifting to the right. If it were x plus 2, where would we shift? To the left. right? So notice this is an x minus h, meaning if there's a minus, you're actually shifting to the right. If it's a plus, that's when you shift to the left. All right, can we do some problems now? All right, I want us to, so let's do some examples. I want us to sketch y equals 2 raised to the x plus 1 minus 1. So the first thing we want to think of is our parent graph. This is what's going on in our heads. And which parent graph is this? Is this the parent graph that's increasing left to right or decreasing left to right? Increasing, because our base is a whole number, not a fraction. We're increasing left to right. So we still have that same key point at 0, 1. This is our parent graph. And we have a horizontal asymptote at y equals 0. So it looks like this. Do we agree that's our parent graph? Okay, now the shifting is all based on that key point. So our shifting should be y equals a raised to the x minus h plus k. So this is x minus h, and this ends up becoming x plus 1. So I'm going to take that key point, and I'm not going to shift 1 unit to the right. Where am I going to shift? 1 unit to the left, because it's the opposite sign. So I'm shifting the key point 1 unit to the left and 1 unit up or down? Down. 1 unit to the left, 1 unit down. So now let's get that on a graph. So our original key point was 0, 1. And now we're taking that key point, and I'm going to shift it 1 unit to the left and 1 unit down, which brings us to the point -1, 0. Now remember, I said there will always be a horizontal asymptote where? 1 unit below the key point. So if this is my key point, I'm going to have a horizontal asymptote 1 unit below it. So at y equals -1. And now once you have your key point and your horizontal asymptote, then it's just a sketch from there. That's all you need. So it looks something like that. I don't care where it crosses the y-axis. I don't care about that. All right, some questions for you. What is the domain here? All real numbers. Soph is holding up the class today. What is the range? Not Soph, somebody else. What's the range? Nico?
-1 infinity.
Good. -1, not included, all the way to infinity, obviously not included. Perfect. All right, let's do another one. Anybody still copying this one?
You gotta find its function or not?
Oh, sure. Is it a function?
Yeah.
Yeah. All right, now let's do y equals 1/2 raised to the x minus 1 plus 3. So in my head, I'm thinking of my parent graph. And the parent graph, when our base is a fraction, isn't it the one going down? So we still have our key point at 0, 1. We still have our horizontal asymptote at y equals 0. But this time the graph from left to right is decreasing. And we are now shifting. All right, so now we are shifting. I'm taking that key point and it's x minus 1. So am I shifting it to the right or to the left? To the right, because it's supposed to be minus. So we're going to take that key point, we're going to shift it 1 unit to the right, and then how many units up or down?
3 up.
3 up, perfect. So we are going 1 unit to the right, 3 up.
3 up from 1.
From our 1 to the right, yeah? So 1, 2, 3. So we were originally at 0, 1. But now I'm taking it and I'm going to go 1 unit to the right and then 3 units up. 1, 2, 3. So now it's not going to bring me up to 3. It's going to bring me up to 4. It's going to bring me up to 4. Right? We went 1 unit to the right from the key point and then 3 units up. All right. This old key point is not in it anymore. That was just to count. And now remember, I'm always going to have a horizontal asymptote where 1 unit below our key point. Now from left to right, am I drawing my function down or am I drawing it up? Down. So I go like this, down, yeah. Looks something like that. All right, our series of questions. Not Nico, not Soph. Somebody else tell me, what is the domain? All reals. What is our range? Yep, 3 to infinity. Is 3 included? No, 3 is not included. Ooh, what is the key point? That's another good one. What's the key point? Nico?
1, 4.
1, 4, perfect. Okay, how about you guys try one on your own and then we'll call it a day? Sound good? Okay.
Are these always going to be a function?
Mm-hmm. It will always be a function. So I want you to sketch, identify the domain, the range, and the key point, and the horizontal asymptote. I'll ask for all those. Domain, range, key point, horizontal asymptote. Oh, after you do this, there's just one more I need to show you. Can we go over it?
Yeah.
You're confused?
Yeah, there's no H.
So if there's no number there, we leave it at 0, right? So let's talk about our parent graph. Our parent graph is key point 0, 1. And looks like that. Do we agree? But what's happening here? This is y equals 2 raised to the x minus h plus k. If there's no h, what is that? X minus 0. So does that mean I'm shifting left or right at all? No. Am I shifting up or down at all? Yes. I'm going to take this and I'm going to shift how many? 3 down. So 1, 2, 3. Here's my key point now. And I'm going to have a horizontal asymptote 1 unit below my key point. So what does that look like? That. So our graph is the blue one. All right, so we did our sketch. Our domain, all reals. Our range is going to be -3 to infinity. Our key point is the point 0, -2. And our horizontal asymptote is y equals -3. You did it right? Yay! Okay, there's one more thing I need to show you. If you have y equals... Oh, was anybody still copying this?
Yeah.
Yeah. Okay. Our graph is not the orange. Our graph is this one. Oh, you said you were still copying.
I thought you meant like because people were putting location after y, like I'm still copying.
Oh, no. Okay. So y equals e to the x. It doesn't matter. What does e represent? E represents some number 2.7 something something something. All I care about is that it's not less than 1, right? That's all I care about. So this looks exactly like our parent function. Just like that. And if I were to shift, I'd shift just like I'd shift on my parent function. That's it. That's all I needed to show you. Now we're done.